Hello everyone, welcome back to my channel. So let's continue with our topic, lathe machine. Today we will study about working principle of lathe machine and various operations performed on it. Working principle of lathe machine. The basic function of lathe machine is to remove the material from the surface of workpiece by the usage of cutting tool, providing the necessary amount of feed, and this can be done by placing workpiece in chuck which rotates with the help of motor. The tool is placed in the tool post and is perpendicular to workpiece for removing the material from the circumference of workpiece such that diameter can be reduced. When power supply is given, chuck start rotating with the help of power transmission system, and workpiece placed inside the chuck also rotates. With respect to type of operation, tool is placed either perpendicular or angular to the workpiece. Lathe machine consists of following operations: facing, centering, turning, chamfering, knurling, thread cutting, drilling, boring, rimming, taping, parting off. Before continuing any operation in lathe machine, we have to load the job and center on headstock spindle. In lathe operations, the headstock spindle holds the job and it rotates with the same speed as the spindle. The carriage holding the tool on tool post. Also, the carriage gives the tool post moves longitudinal and cross-side direction to give desired feed on the job. These two motions help to remove chips of metal and give the proper shape of the job. Facing operation. It is the first operation done on the workpiece. It is machining operation that is done to produce flat surface at the ends of the workpiece. This operation is performed by feeding the tool perpendicular to the axis of rotation of chuck. The work is revolved in the center and facing tool is mounted on tool post, and cross feed is given to the tool with the help of cross slide. Centering operation. It is the operation of producing conical hole in the workpiece so that it can be held between chuck and dead center. For centering operation, a combination drill or countersink is used. Drilling and countersink hole has the same angle as lathe center so that lathe center fits well into the hole. The standard included angle is 60° for general class work and 75° for heavy duty work. Turning operation. In turning operation, excess material is removed from the surface of the workpiece to produce a cylindrical surface of desired shape and size. During the turning operation, feed is moved along the axis of rotation of the chuck. It reduces diameter of cylindrical workpiece. following types: rough turning and finish turning. Rough turning is done by taking heavy depth of cut and giving high feed rate to reduce machining time. During rough turning, work is revolved at lower speed and cutting speed is low. Depth of cut varies between 2 to 5 mm and feed rate is 0.3 to 1.5 mm per revolution of the work to produce rough surface finish. Finish turning requires high cutting speed, small feed rate and small depth of cut. It gives smooth surface finish. The depth of cut ranges between 0.5 to 1 mm and feed rate is 0.1 to 0.3 mm per revolution of the work to produce finished surface. Step or shoulder turning. When workpiece having different diameter is turned, the surface forming the step from one diameter to other is called shoulder, and the machining this part of workpiece is called as shoulder turning. Different type of shoulder produced are square shoulder, beveled shoulder and radius shoulder. Taper turning. Taper turning is a turning process in which cutting tool moves at an angle of the axis of workpiece so that workpiece receive taper shape. In tapered piece, the diameter of workpiece varies uniformly from one end to another. The workpiece can be tapered from inside or outside. Taper may be specified by tan alpha equal to d1 minus d2 divided by 2L, where alpha is equal to tan inverse d1 minus d2 divided by 2L. d1 is larger diameter of taper in millimeter, d2 is smaller diameter of taper in millimeter, L is length of taper in millimeter, and alpha is half taper angle. There are various methods of taper turning. The first method is taper turning by form tool method. A form tool having broad nose is used for short external taper turning. The tool is grounded to half taper angle and feed to work perpendicular to lathe axis to obtain desired tapered shape. It is used for small taper lengths, example chamfer, heads of screw, etc. The length of taper is limited to the width of tool. The second method of taper turning is Taper turning by swiveling compound rest method. In this method, tool is fed at an angle to axis of rotation of workpiece. The tool is mounted on compound rest. The cutting edge of tool is accurately set at the center line of the workpiece. The compound rest has circular base which is graduated in degree. It is swiveled to half taper angle and clamped. After setting the compound rest at half taper angle, rotation of hand wheel causes the tool to feed at angular direction, generating corresponding taper on workpiece. The third taper turning method is taper turning by set over tailstock method. In this method, the axis of rotation of workpiece is made inclined at an angle equal to half taper angle with lathe axis by setting the tailstock center. Tool is fed parallel to axis of lathe. Setting over tailstock is done by sliding the body of tailstock towards or away from the operator by means of set screw. The amount of set over is limited, hence method is used for turning small taper on long slender jobs. It requires use of ball type dead center. The next method of taper turning is taper turning by taper turning attachment. In this method, work revolves between the center or with the chuck and tool is guided in straight path set as an angle to axis of lathe by using taper turning attachment. The taper turning attachment is fitted on rear end of the lathe bed. Taper turning attachment consists of frame, guide bars and guide blocks. The frame is attached at the rear end of the lathe bed and supports the guide bar pivoted at the center. The guide bar has graduation in degree and it can be swiveled either side of the zero mark and set to desired half taper angle with the lathe axis. When taper turning attachment is used, cross slide is first made free from the lead screw by removing blender screw. The rear end of cross slide is then tightened with the guide blocks by means of bolt. Tool moves with the guide block with slide on guide bar set at an angle of lathe axis. When longitudinal feed is engaged, tool travel in angular direction to generate corresponding taper on workpiece. Chamfering operation. Chamfering is operation of producing a bevel-shaped finish at the end of the workpiece. Chamfering is done for removing burrs and for protecting the ends from getting damaged. Chamfering is essential after thread cutting operation. It may be performed after turning, knurling, boring, drilling, etc. Knurling operation. Knurling is the operation of producing a diamond-shaped pattern on surface of workpiece. The purpose of knurling is to provide an effective gripping surface on a workpiece to prevent it from slipping when operated by hand. It is provided on handle of machines and gauges. It is done by knurling tool which consists of hardened steel rollers in a holder. It have a teeth cut in a definite pattern on their surface. This tool is held rigidly on a tool post and rollers are pressed against the revolving workpiece. get impression in a regular pattern. Parting off. It is the operation of cutting a workpiece after it has been machined to the desired shape and size. In this operation, workpiece is rotated at half the speed that of turning, and narrow parting of tool is fed perpendicular to the lathe axis by rotating cross-slide hand wheel. The carriage is locked at particular position before start of the operation. Drilling operation. It is the operation of producing a cylindrical hole by removing metal by the rotating edge of the cutting tool called as drill. The workpiece is held in chuck and drill tool is fitted in tailstock barrel. The speed and feed for drilling operation is 25% lower than normal speed and feed used on drilling machine. Boring operation. Boring is the operation of Knurling the hole by removing metal by the rotating edge of the cutting tool called as drill. The workpiece is held in chuck and drill tool is fitted in tailstock barrel. The speed and feed for drilling operation is 25% lower than normal speed and feed used on drilling machine. Boring is the operation of enlarging the holes produced by drilling, casting, forging, etc. Boring cannot originate hole. The work revolves in a chuck and boring bar is fitted on tool post which is feed longitudinally. The feed of tool is given by cross feed of carriage. thread cutting operation. Thread cutting is one of the most important operations performed on lathe machine. Internal as well as external thread can be cut on lathe machine with the help of threading tool or with the help of tap and die respectively. The principle of thread cutting is to produce a helical groove on a cylindrical surface. The tool is sped longitudinally against workpiece which is rotated at slow speed between the center or by chuck. The longitudinal feed of tool must be equal to pitch of threads to be cut per revolution of workpiece. The workpiece rotates about the lathe axis slowly with the help of back gear. The lead screw shaft is connected to lead screw and spindle through change gears, and movement of tool with carriage is obtained by half nut mechanism.